Hello, everybody. Welcome back to our ChickQuest adventures. We are so excited that you are here to learn about eggs, chickens, and science. Remember, this is sponsored with Grow Next Gen and the Ohio Soybean Council and the partnership with educationprojects.org. All right, today we are going to talk about egg physics. I'm going to give you a problem, and we're going to use our brains and our powers, put on your scientist caps, to decide how to determine if an egg has one property or another. So let's get started. Oh no, everybody, Busy Chef has a problem. All of the eggs on this paper towel were put together in his refrigerator. He needs to know if these eggs are table eggs or hard-boiled. Let's look at these eggs. Can you tell a difference? Can you shake an egg and determine if it's hard-boiled or a raw table egg that you would use to make scrambled eggs, for example? What do you think? What are some ways that we can problem solve to determine if this egg is in solid form or if this egg is in liquid form? Let's see. I can shake the eggs, but I really can't feel a difference. Can you? If you have some eggs at home, pick them up and see if you can tell a difference. What are some ways that we can problem solve and determine so that Chef doesn't have to take the time to crack every egg open to see? That would waste a whole bunch of eggs, and we don't want that to happen. So let's think out loud, what can we do? Okay. I shake the eggs, but I don't hear them telling me anything. So we're going to do some experiments on the table. Just a second. Remember, Busy Chef is busy. And what that means is he only needs 2 hard-boiled eggs. But I have 5 eggs here. Some of them are raw table eggs. And if I crack them open, they're going to spill all over the paper towel. A couple of them are hard-boiled. So we have to figure out how to determine that. Just a second, having some complications here. All right, so one of the things that we can do is we can decide some testing. Sometimes testing will help us to decide if it's hard-boiled or not hard-boiled, so a raw table egg. But sometimes testing may not tell us any differences at all. One of the things that I think we should do is spin our eggs. So we're going to take some time to spin each of these eggs and determine if we see any differences. Let me smooth out my paper towel here real quick. I'm going to take this first egg and I'm going to spin them all like this, counterclockwise, like you'd spin a quarter. Uh-oh, let me move my paper cloth here. This is giving me some problems. Here we go again. Look at how it spins. Pretty uniformly. That means at a similar speed. It's moving around the table a little bit at first when it begins to spin, and it slows down pretty quickly. Let me try another egg. Sorry about that. Oh my goodness, this one's traveling a lot, but it's spinning a lot faster, guys. And it's wobbling a little bit, but not too bad. Let me try it one more time. There we go. So it's doing like a circle around the table. Can you guys see that? Take an egg of yours at home and spin it just like I have. Okay, now let me try a third egg. See what happens. This egg is spinning slower again, like the first egg. This egg might have properties that are similar to the first egg, and it slows down a lot faster. Let me try it one more time. It seems to spin at different speeds too, like it turns and then it slows, and then it turns and then it slows. Let me try this egg one more time that was a fast spinner. Wow, look at that one. I'm going to spin this other egg at the same time. They're traveling off the camera, but you can see that the first egg is still spinning while this second egg is slowing down quite a bit. Let me try that one more time, and then we'll make some conclusions. Uh-oh, again, off the table. Gosh, I'm not a good spinner, am I? Here we go. Whoop, it hit another egg. These eggs, whew, they're travelers. Well, we did notice some differences. Let's go ahead and put our data together. This egg spun much faster, but it also traveled around the table. When it spun in a more uniform pattern. So as it turned, it didn't turn at different speeds, but instead it turned at the same rate. This egg spun much slower. So as it turned, it seemed like one end turned faster and then a little slower, and then faster and a little slower. And it definitely wobbled while it turned. So that helped to slow our egg down. So when we're looking at these eggs, these are really important properties to think about. This is a fast spinner. It didn't wobble as much, so it was able to travel around the table. This egg was a slow spinner, and it wobbled, and it even spun at different rates as it turned. These eggs are definitely different from each other. So let's just take these two eggs and do some more testing. Another possible test that we could do would be to float the eggs. Have you ever heard about that? If I float eggs in water, will it tell me a difference? Well, let's see. Let me get my paper towel back. I have prepared for you guys a bowl with regular water and a bowl that I have super saturated with salt. Now you might ask, what does super saturated mean? Super saturated means that I have added so much salt that it will no longer dissolve in the water. Do you see on the bottom of this bowl, when I move my finger, the salt crystals that are still there? So I have stirred this water so that it will not dissolve any additional salt. So that's why we call it super saturated. Now let's take that first egg that spun a little slowly and wobbled around the table. I'm going to put it in my water and see if I notice anything happening. Well, it looks like it's just laying there in the water, doesn't it? It's moving a little bit with the water motion, but I don't see it standing up or doing anything very unique. Let's put in the other egg, see if something happens with this. Well, this egg kind of traveled in the water too with the water motion. But again, I don't see that anything real unique is happening. It looks like each egg rounded end is up just a little bit. Let's do that again, just so we can confirm our data. The first egg, the slow traveling egg, laid in, and I'm going to show you on the camera, looked like it just tipped up a little tiny bit. Now I'm going to do that with the fast traveling egg and watch it do the same thing. Now you can do this at home. You can have a bowl of water. You could try other liquids, maybe liquids with different densities. Think about milk or juice that you could submerge your eggs in. Now let's take them over to the super saturated salt water. First, I'm going to put in the slow traveling egg. How does salt affect the density of the water? If you were to float in regular water, do you sink, or swim? Some people sink better than others or swim better than others, right? Same with eggs. Did I notice anything happening here? It seemed very similar to what I saw in the water without salt. They both kind of came in and settled and then tipped up just slightly on their pointy end. Let's try that again. First, the slow egg, settling and a little tip up, and now the fast egg, settling and a little tip up. So let's just think about the data we have learned again so far as I move these bowls away from the camera. This fast traveling egg that you see here today moved a little bit faster in a more uniform pattern, and it traveled in a bigger circle around the table. This slow moving egg that you see in my hand today turned slower, it wobbled as it turned, and it stopped spinning faster than this other egg. Both eggs, when they were in the water, kind of settled and then tipped up just a little bit. So that seems a little bit more inconclusive. The data doesn't really tell me as much, so I think we need another test. One test that we're going to do soon is we are going to candle eggs. And there are professional candle machines that you can use that have a high intensity light, and that light will allow you to look through the egg. But I don't have that technology at home on my farm. However, I do have a light. If you have a phone or an LED flashlight, you can do this at home too. I'm just taking my cell phone and I turn the flashlight on. Ooh, all right, now I'm going to put the egg on top. Look at that. The egg is glowing and light yellow. Isn't that cool? This high intensity beam can travel through my egg so I can see it in fine detail. Let me show you on the other camera. Can you see in that egg? All right, that light is traveling through the material of the egg and being emitted on the other side. What that means is that the material on the inside of the egg is translucent. It allows light to travel through. Let me take the other egg. Sorry about that. Do you see the same emittance of light coming through? This egg just looks kind of white, doesn't it? If I move the egg around a little bit, I will see some inkling of light in some areas. Ooh, in this area in particular. Let me show you on the other camera. Do you see that I can see the light travel through this egg just a little bit on this rounded end? But when I put the light here, it's not traveling through very much. So that means that this egg is not translucent. Instead, it's solid on the inside. Guess what? This is the hard-boiled egg. Let me prove it. This other egg, remember, the light was able to completely go through. This is not a fertilized egg, it's a table egg. And because of that, all you see is the liquid contents inside. This was the slow-moving egg. Wow. Let's go ahead and think about what we learned today. A table egg, a raw egg, a liquid egg, so the insides are still moving in there, travels more slowly on the table because the contents inside of the egg are moving back and forth as it spins. This makes the egg slow down and causes it to wobble. This egg is a solid egg, a hard-boiled egg, and so when it spins, it doesn't have anything that's moving around inside. Instead, it's all in one place, allowing it to spin faster and move a little bit in a bigger arc around the table. When I tried to float these eggs both in regular water or salted water, I didn't see any difference. So that was kind of an inconclusive test. Remember, you can do additional tests at home. What else should you do? Are there other things that you know that change physical states? Can they go from liquid to solid or even a gas form at home? Okay, you guys, thanks for joining us today on our ChickQuest adventure. We are really excited that you are here. Remember, Ohio is our #2 egg production state in the country, and that's because we grow soybeans here and the chickens love them. We'll see you tomorrow. We're going to use some more technology and candle some eggs to see how our chicks are developing inside of the incubator. All right, you guys, take care.